We're going to talk about OSGi. And since we're with like 5 people in the room, I can actually ask you, do you have any experience with OSGi? I already asked you just now. A little bit? Little bit? Excellent. So that will be pretty good. So this talk will show you some of the reasons why I think OSGi is a good technology to use. And that also gives like a little bit of a view on how I do OSGi development. Because if you look at the internet at how people approach OSGi, I think a lot of people miss out on actually some very useful tools and libraries, etc., and making their lives a lot more difficult than it should be. So hopefully you will get out something of that. So my name is Paul, I'm from the Netherlands. I wrote this book, which at least one person read, so that's good. And most of my work is around developing open source stuff at the moment now, mostly within Amdatu, which is one of the libraries that we will take a look at in the talk. I'm also a committer on BND tools, which is the tools that we will be using. And besides that, for the past few years, I've been doing, primarily OSGi development. Before I started doing OSGi, I actually came from just a consultancy job and even did teaching for a few years. And I was always doing that within the Java space, but never with OSGi. So there was always Java, Spring, many of the other frameworks that came and go again. So I do have kind of a lot of experience with technologies besides OSGi, so I can compare them nicely. But when I started with developing OSGi, that was when I joined Luminous, the company that I'm now working for. That was about 4 years ago. And Luminous already did OSGi development even before it was called OSGi. So that's about 12, 13 years now. So I kind of get a deep dive in getting introduced in OSGi because, I was working with people who knew literally everything about it. And I started to see that it actually made development so much easier than what I was what I was used to. Everything started rolling from there. So let's get started. So probably the most important reason for me, at least, why I like OSGi this much and why I think it's better than, most of the other frameworks, actually all of the other Java frameworks, is because of the developer productivity that you get with it. Well, we've all seen this picture probably, but let's take a look at how typical Java development looks like. Well, you write some code, maybe that was just a few lines of code that you actually chanced. Then you go to do a Maven build. Even if it's supported in your IDE, it's still doing a Maven build, which takes a while. Then that result should be deployed to an app server, which takes another few seconds. You have to reinitialize the application, you have to log in again, and, that all kind of makes me sad. I mean, it just feels horrible. I did quite a lot of development in other languages as well. I did Groovy and Grails for a while. I did some Ruby. Did some JavaScript quite a lot. So coming from those experiences, it feels very painful to actually make code changes and wait. It's so much nicer if you can just keep on coding, see your changes directly in your browser or whatever you're working on, and that just makes everything a lot faster. So in OSGi, given that you're using the proper tools, it very much feels like using a scripting language. Of course, it's still Java. It's still Java as we know it. But you have this development experience that feels very much like working with scripting. So let's just take a look at how that actually looks like. So I've got this code here. It's just a RESTful web service. Let me actually make sure that I can see my screen myself as well. Yep. that's a lot better. So I've got this RESTful web service. Doesn't really matter what the code does because this works everywhere in your code. It's not specifically about this RESTful web service. But I've got this RESTful web service, and actually the RESTful web service is not what I'm currently showing. That's this code. So I've got this RESTful web service, and this RESTful web service just returns some JSON that we have, and it uses this chat room resource or chat room storage service that returns me some data. And that was the code that we were just looking at. So let's first of all just take a look if you can run this. So I've got a so-called run configuration here. We'll not go into the details there. But from your IDE, you can just run this, and it will start an OSGi framework, and that framework will include my code. So when this is started, I should be able to go to my browser and see something on port 8080 on the endpoint that I just defined in the code. Okay, well, that's pretty good, I guess, but not that interesting. Starts to be interesting when I just start changing my code. Okay, so I have my code here. Let's click Save. I don't have to recompile or anything. Just refresh, and it's in my browser. And this is why OSGi is awesome, because you can do this without falling back to like a scripting language and have all the downsides that comes with it, because it's still just Java here. And as I said, this works everywhere in your environment. This is not just about this RESTful web service. So how and why does this actually work? Well, if you look at how OSGi works, every bundle in OSGi, every module, has its own class loader. Well, you don't really have to care about it. You don't even have to know about that, actually. But that's how it is. And OSGi, the framework, is designed to be hot updatable. So you can have a running framework in OSGi and just update a bundle, a module, in that running framework without restarting the framework. So what my tool is doing here, I was just running Eclipse with a plugin installed called B&D Tools. What B&D Tools is doing for me is every time I compile some code, that's what Eclipse automatically does anyway, it will take that recompiled code in that specific project that builds my module, rebuild that module, that's just one jar file to rebuild, and update that jar file in my running OSGi framework. And my code is there. Rebuilding a single jar file, of course, takes, I don't know, microseconds. It's not even a second that you have to wait for it. So it feels like almost instant that your code is there. It takes longer to actually alt up back to your browser than it takes to reinstall this code. This also means that this whole mechanism works everywhere in your code. It's not just only in the web layer or only in, well, with some limitations. This just works everywhere. OSGi is designed to be dynamic, and that means, well, you can use this wherever you want. If you compare that to, well, obviously to something like rebuilding with Maven, because that's slow, but even if you're using a tool like Gradle, which is a pretty cool tool, that's a, well, a class loader that kind of mimics what OSGi is doing. But Gradle is just a hack. It works around the issues of, well, the class loader model that Java normally has. It's a very cool hack because they kind of get it to work, so it's pretty cool. But it's still a hack. And that means that it kind of works sometimes, maybe most of the time, but not all the time, which is very annoying because I've worked with it for quite a long time. And every time something doesn't work in your code, you're testing it, you're like, did I just introduce a bug or did Gradle mess up again? And I just hate asking that question. So this feature alone should be enough to switch to OSGi. But I've got like a few more reasons to do this. Another thing that I think every Java developer hates is class not found exceptions, and I've seen plenty of them. The problem with class not found exceptions is that they tend to occur in production instead of during development, because depending on the jar files that you manage to deploy somewhere, your deployment might or might not contain all the classes that you will use in production. The problem with this is that it will not blow up during deployment most of the time, but it will actually blow up when someone hits a code path in this production application that loads that class, because the classes are loaded on demand, basically. And then you get this kind of ugly class not found exception. So the problem is not that class loading is bad or difficult or whatever. The problem is definitely not in this specific example of Spring. This can happen anywhere. The problem is that there's no fail fast mechanism. So let's see how OSGi makes this better. In OSGi, all your code is of course packaged in OSGi bundles, in modules. And those bundles have to explicitly define what code they need from other modules. And everything that is not contained in your own bundle must be imported from somewhere else. This must be explicitly defined in a manifest file, in headers. And because those headers are then available in a module, when you install the module in a framework, the framework can actually verify that some other bundle exports this class that you're looking for. And if that's not the case, well, there's something wrong with your deployment, and it can immediately tell you something is wrong with your deployment, and there's more work to be done, instead of just, well, lazily waiting until it really blows up. The good thing is that this, this manifest header that you have to write will be generated for you, again, using BND tools. So let's take this code as an example. It doesn't matter what the code does. Well, actually, it doesn't do anything because it's empty. But take a look at the top of the class where it does the imports. So we're importing two classes from the felix.dm package, and we're importing a class from the OSGi framework itself. My tool will now analyze the bytecode produced by the compiler, and it will do that every time I actually compile it, and it will automatically generate this kind of import package statements, and that will be part of my bundle. So just from reading this import statements, it learned that we're using a package from felix.dm, so that must be imported, and we are importing a package from OSGi.framework. And you also see that it has a specific version range. So in this case, we say that for felix.dm, we want to have anything larger than version 4, major version 4, but we don't want to switch to version 5. And, well, you could fix it on a specific version. You could make it a different kind of range. But this way, well, you're kind of safe in the way that if felix.dm uses semantic versioning, you're kind of sure that up until the next major version, there will not be any breaking chances in the API, and you can safely upgrade to the new version. That's what's written here. So again, this is all generated for you. You don't actually have to write this by hand. Now let's try to actually install this bundle. So I'm installing this bundle that contains the code that we have just seen. And I forget to install the dependency manager bundle. The framework will then immediately blow up, and it will tell me, well, something is wrong, because you're importing this apache.dm package, but nobody exports it. It's not available in your framework, so this is not going to run. That's pretty good, because instead of blowing up at some random moment for some unlucky user in production, I now immediately see, oh, I made a mistake and I have more work to do. If you are just using the tools, so if you're using BND tools, but also if you're using Maven in combination with the BND plugin, this will be done for you. So there's absolutely nothing that you have to do for this, and that also means you can't actually mess it up, because it's just doing bytecode analysis, and well, that will never go wrong. So class not found exception problem solved as well. We've just seen this import package statement, and we have seen that you can import package a specific version of a package. That comes with a nice side effect, and that side effect is that you can have multiple versions of an API installed next to each other. this is actually pretty good because if you're using libraries, that libraries might have dependencies on other libraries. So for example, I'm using a library, and that library depends on SLF4j for logging. But maybe it depends on a specific version of SLF4j. My own code also uses SLF4j. Different version though. If you have a traditional Java deployment, well, one of those 2 jar files will end up in production. If you use Maven, you will never be sure which one of those. That depends on ordering, etc. And well, that might or might not work. That only works if that jar file happens to be backwards and forwards compatible. With OSGi, we know about those versions, and we can, if you want to, even install just both of them. And my library will use the correct version for him, and I will use the other version that works for me. That's actually also an important thing to have. The other thing we get for free, basically with this whole mechanism, is that we can do semantic versioning, which means we can actually analyze the bytecode again and look at a version of our last release, and the tool can tell us, well, you have breaking chances in your API, and you have to do a major upgrade of your version. And if you start using that, it starts to be much safer to do new releases of your software because you actually know if you did breaking changes, maybe by accident, maybe not, or that is just a micro update that should be no problem at all to install. Next reason, something completely different, about deployment. And that can be cloud deployment, but actually that goes for any kind of deployment. If you just install on some server in your data center, it's the same thing. So the first reason why it's very easy to install OSGi applications is because there's no application server. We just don't need it. The thing that we use for deploying our applications is just creating an executable jar file. So we generate one jar file that contains the framework itself and all the code and libraries that I use. Wrap that up in one single jar file, which is executable, and we could just start it with java -jar myapp.jar, which is very easy. Because we have this single jar file as a result of our build, it's also very easy to start building Docker containers if you're into that. Because, well, you don't have to install any kind of dependencies on the Docker image like an application server. It's just this jar file, and you of course need Java. That's it. The footprint of an OSGi application is also very small. And with that I of course mean the footprint of the OSGi framework itself. That's close to nothing. Well, compare that with something like WebSphere, which is, well, a little bit more than close to nothing. So how do you actually build a binary like this? Well, if you use BND tools again, every BND tools workspace comes with a Gradle build out of the box. You don't have to write anything for that. And using this Gradle build, we can of course, well, run something on a build server, and we can just do Gradle build, which builds a project and runs all the tests, and use export to actually create this executable jar file. This executable jar file can then be started with java -jar myapp.jar. And it's that simple. And again, this is all working out of the box, so you don't actually have to know about Gradle or stuff like that, well, unless you want to extend it. But for basic builds, everything is there, and you just have to run it. In case you're working with Docker as well, this is how a typical Docker image looks like if I'm looking at our deployments. So we use a very lightweight busybox-based Java image, contains Java 8. We just have to copy the jar file that we just generated with Gradle to this image. We expose some ports, and we just run the jar file. That's it. And that's a lot easier, of course, than installing an application server, making sure you do all the layering correctly so that the build doesn't get very slow. And the images are very small as well, because the only thing we need is busybox. The thing I'm working on right now is actually commercial support for all of this, for doing like large-scale deployments in the cloud. with things like full automation of deployments, blue-green deployments, etc., logging and monitoring, which is a large part of it. So this is not so much specifically about OSGi, but more about the infrastructure that we run on. But OSGi is a first-class citizen here, because all the logging and monitoring is specifically tuned to work with OSGi as well. So that could be interesting as well. Reason number 4, maintainable architecture. And well, if you look at the picture carefully, at the beginning of the sentence, you see something went wrong here, which is, well, weird. We don't want that to happen. But actually, if you look at a lot of software projects, you see this happening all over the place. Well, at least a lot of projects that I have been involved in the past. If you look at the first 2 months of development, everything is super cool and development is fast, etc. And you're actually making progress, actually building stuff. That's all really good. But then after 6 months, things tend to slow down a little bit. You are actually fixing a bug and managed to introduce 3 new bugs along the way because, well, there were side effects that you didn't foresee. The code starts to be a little bit messy and unreadable. It starts to be hard to find your way through it. And after a year, you just want to run away and, well, find a new job or something like that. Well, of course, OSGi is not a magic bullet. It's not going to automatically solve all those problems. It's very much possible to create a big mess and a big pile of mud with your source code using OSGi. So it's not happening automatically. But with OSGi, we have a lot better tools to actually create an architecture that is much more maintainable. And the key aspect there is implementation hiding. So that's, of course, basically just what we have learned about object orientation as well. If you think about modules, those boxes on the screen, those boxes should be self-contained, basically. Of course, there's coupling within those boxes, because without any coupling, well, nothing will ever work. But that should just be one self-contained part of my application. And that part should be very small. It should just do one single thing, and it should be good at doing that single thing, but nothing more. To the outside world, to other modules in my system, there's only an interface. And this interface, that's what the outside world knows about, and it shouldn't care or shouldn't even know about implementation details or whatever the way is I implemented it. Think forward a little bit. This also sounds very familiar if you're into the whole microservices story, just on an architectural level. So why does OSGi help here? Well, in OSGi, we have already seen that you have to explicitly import and export things in your bundle. So we can actually do proper implementation hiding, and we can do that even at runtime. So all the checks are there during runtime. So if someone made a mistake somehow, we will notice it immediately, and it will actually not work. So having our bundles have to explicitly state which packages are public to other bundles, to the outside world. Anything that is not exported explicitly is internal and can't be loaded by other bundles at all. Then we have the concept of services to actually provide functionality to the outside world. So in OSGi, we have the service registry. And a bundle that provides some kind of service can basically just have a Java interface and register the implementation that it has for that interface to the service registry. Another bundle that is interested in that interface can then ask the service registry, please give me an implementation of this interface. And the service registry will take care of that, and we will see how to work with dependency injection in a moment. But that bundle using the service doesn't know where this implementation is coming from. It doesn't know from which bundle it's coming. It has no idea about its implementation. We can actually just swap the implementation with a new implementation without the other bundle knowing about it. So this is true decoupling, and that's probably the most important concept if you want to have a maintainable architecture. Let's think about this. This looks like a very typical architectural diagram of a Java application, right? We have some tires, I drawn 3, maybe there are 5 or 7 or whatever, depending on which year you were stuck in the integration patterns book. But we have some layers. The problem is in Java, if you start to actually build this, is that, well, they all start to be big balls of mud sooner or later. Sure, we have a separation of concerns when it comes to our data layer is only about data. But if you have a large application, well, there's quite a lot of data to be handled and quite a lot of Java code around handling that data. Should that just be a single Java class and a single Java interface? Or should it be 3 or 5? Or, well, there's no rules there. And you see that, well, I've seen a lot of projects. I've also been doing a lot of code reviewing in the past. And most projects just end up to have like this huge data service that, well, basically takes care of everything database related. And of course, that becomes completely unreadable after a while. So what we want to do is we want to split that up in smaller parts. Most of the time, you want to look at your functional domain, and on the other side, we still have the technical domain. So we have the technical domain of data, and within the data layer, we have the functional domains that we recognize in our application, and all of those are separate modules, exposed as separate services in OSGi. It's not that you cannot do this using something like Maven, for example. Sure, you can. But it's a lot more trouble to actually make that working with like multi-module projects, etc. So it's a lot more work. And there's no runtime checking. So if people start to mess up at some point, and well, it's very easy to mess up if the tools don't prevent you from doing so, well, sooner or later it starts to be a mess anyway. So that's why we need this well, stronger encapsulation and stronger decoupling. This is an architectural diagram from a sample application that we wrote in OSGi, which is also available on Bitbucket. And every box here is actually an OSGi service. So actually the gray ones are OSGi services, the rest are data stores. And the nice thing about this is, well, of course, anyone can draw this kind of diagram. And ask any architect and he will draw up something like this for any kind of system, right? But then when you start looking at the source code, most projects will look very different than this picture. It's often very difficult to actually recognize the picture if you map it to the source code. And you're like, really? Is that the same thing? If you look at an OSGi project, and again, this is just a sample project, so it's a very small one, but it's exactly the same thing for bigger projects. Let's take a look at the picture. So we have this room resource. That's one OSGi service. So we have a chat.rooms project here, and this chat.rooms project generates 2 different jar files, 2 different modules. And that means that this REST jar file just contains the RESTful web service for chat rooms. That's it. If we look at the messaging part, this generates a single bundle. The messaging part contains the RabbitMQ connection that was shown on the diagram, and nothing more. And that goes on forever. And this is, as I said, a sample project, so the project is pretty small and there's not a lot of bundles here. But the size or the amount of code packaged in a single bundle is actually very realistic. So if you look at our very large applications that we have, we also most of the time have a single class or a single service as part of a single bundle, because that gives you the most flexibility and most modularity. The nice thing of that is that it becomes very easy to actually completely redo an implementation. For example, in this picture we're using RabbitMQ. What if I want to get rid of RabbitMQ because I'm not happy with it and I want to switch to ActiveMQ or whatever? You can very easily see from this diagram where the problematic code will be. That will be in the RabbitMQ service. That's the code that I have to change. All the other modules that I have don't depend on RabbitMQ, I'm very sure of that, and the only way to actually use RabbitMQ is through that RabbitMQ service. That means if I keep the same interface, but I re-implement it based on ActiveMQ, I don't have to change any of the other code, and I'm absolutely sure about that, because I'm hiding that implementation detail. In practice, in the projects that I've been working on in the past few years, we actually have been doing this quite a few times. You do the first implementation, you use that for a month or so, you learn from that, and after a month you see, well, okay, the idea is basically working, but because we didn't know everything at that time when we were writing it, we made mistakes. And if you would redo it, we would do it a lot better. Maybe better performance, maybe better readable code, whatever. Using this modular architecture, it becomes very easy to just say, well, I'm going to throw away this whole implementation and I'm just going to redo it. I keep the same interface, but I just re-implement it. Well, what are you throwing away? It's 100, 200 lines of code. That's absolutely no problem. I mean, you can rewrite it in an afternoon or so. The important thing is that you can actually do that, because you're sure that you don't affect the other modules in your system. And that makes it a lot easier to actually make this choice of throwing away code and re-implement it. And that's a very nice thing to have. Right, reason number 5. Add service dependency. We're talking about dependency injection here. Dependency injection is a good thing, of course. And we need the same thing in OSGi. We have already seen that in OSGi we have this concept of services, and one service can use other services. And that's exactly what we're doing here. So this is just an example of a bit of OSGi code, and this is an OSGi service. So we have a Java class, and the Java class implements a demo interface. And using this add component annotation, we're actually registering this implementation in the service registry. And that's all there is to it. We're also using some other awesome component, as you can see there, and we can inject that by just using the add service dependency annotation. That's it. And then there's things like lifecycle methods. And of course, this looks very similar to using something like Spring or Java EE. And that's actually a good thing, because the dependency injection there is very easy to use. But if you look at, well, people complaining about OSGi, they often complain about the fact that it's so difficult to work with services. The reason for that is that people getting started with OSGi often get into the low-level APIs of doing service registrations. That low-level API is called low-level for a reason, because, well, it's hard to use, and it's actually designed to be like a core layer where other people will write frameworks on top of, like this one. So if you're doing this low-level API, you have to take care of a lot of threading issues that you have to be careful with. There's a lot of tracking of things coming and going on, because, well, in OSGi services can come and go during runtime, because we can do this hot updates of the framework. So just don't do that. Use something like Apache Felix Dependency Manager. That's what I'm using here, or one of the other solutions. Just use annotations or Java API. We have Java APIs as well, and let someone else take care of this difficult stuff. And by that, it's really not more difficult than using Spring or whatever. Different topic again. People have been talking a lot about microservices. Well, there's a lot of wrong reasons to get into microservices. I think a lot of people get into microservices right now because everyone is talking about microservices, and it seems to be the thing to do. That's of course a bad reason, but there's also a lot of good reasons to do microservices. A good reason to do microservices, and I'm talking about microservices here like full-scale Netflix style microservices. The reason why this is necessary for some companies is because their software becomes so large that they need multiple teams working on this code base. Well, working with a team of 50 people on the same code base, you know that's a recipe for failure. That's not going to work. People in the past have tried that. It's not going to work. You need small teams focusing on a single thing. If you have this situation, it makes a lot of sense to actually split up your code base in, well, let's call it microservices, and let each team be responsible for such a service. And make them responsible for the development, but also for the operation side of things. So let them have their own release cycles, let them deploy and monitor everything themselves, and if it breaks, it's also their responsibility to fix it. That makes sense, if you ever get to that kind of team size. If you're starting a new project, it doesn't make any sense to actually do those early microservices splits, because you're probably working with a single team at that moment. Using things like remoting, etc., will just slow you down. It will make it more difficult to develop. And that's why, recently actually, people started to wonder, are microservices actually the way to start? You might have seen the interesting article by Martin Fowler, where he said, and introduced the concept of monolith first. Sure, maybe at some point in the future you need microservices, because the reasons I just discussed. But it's probably not a good idea to start with it from the beginning, because you will probably end up with the wrong services anyway, because, well, you don't know exactly what you're going to build yet, and it will just slow down development. So he introduced the concept of monolith first. You first build a monolith, and then redo the whole thing as microservices when you actually know what you're building. I don't necessarily think that's a good idea, because, well, I'm afraid that you will actually will be stuck with a monolith forever. That's what happens in most companies, to my experience. So I wouldn't say do that. But using OSGi, we actually have a nice middle ground to that. It's a very nice way to start with just a single VM architecture, and then migrate slowly to full microservices when you need it, which means when you have more than one team. So why is this? Well, probably the most important thing to get right to actually get started with microservices is modularity, because you have to define the scope of your services, which is the same as defining the scope of modules. So if you already have a service-oriented architecture in OSGi, because we're using services there, they were actually called microservices before microservices, well, started to mean something else, but that's besides the point. We already had this modular architecture. The only thing we have to do when we want to have full microservices is introduce remoting, splitting of the code bases, and splitting of the deployments. Sure, still work, but at least I don't have to change much of my code. This can actually get even easier when looking at OSGi remote services. That's an OSGi specification which is all about remoting. We already have the services concept, but OSGi services are typically, well, are always within a single Java virtual machine. But with OSGi remote services, we can actually have multiple Java virtual machines running on different hosts, and they can still communicate as if they were running on the same machine. The remote services specification has a pluggable discovery and transport, so you can use different transport mechanisms. You can use different ways to discover which services are available on your network. So there's an implementation based on Zookeeper, on etcd. You can just give it a static list of IP addresses. You can do broadcasting. There's all different kind of implementations. But this makes it very easy to migrate from like an in-VM service architecture to multiple VM, and with that, microservices. So just a code example how this would work like. We've already seen the service dependency just now. And you see that the client here is still using the same as service dependency annotation. On the server side, so on the side that actually exposes the component, we have to do one chance, and just introduce a new property on my service. So by default, nothing is exported remotely, but using this service exported interfaces property, my service will be exported and will be registered in, well, Zookeeper or etcd or whatever we're using, so that others can use it. That's it. And you see how easy it would be to actually migrate your code from one VM to multiple VMs. I'm not saying that doing this RPC style of communication is always the best way to approach this kind of architectures. Maybe a messaging style would be a much better fit. That would be, well, more work, because then you have to think about working working asynchronous. But this at least gives you a very easy path to split things up. All right, next reason. You have all the libraries you need. And we have the Amdatu logo here. Amdatu is one of the projects that I'm working on. Amdatu is fully open source, it's Apache licensed, and the goal of Amdatu is to provide all the components you need to build something useful using OSGi. So we have support for REST, we have, well, that's what we have already seen, things like scheduling, Mongo support, JPA, etc., etc. It's all there. So you might wonder why use Amdatu, why not just use Spring, because everyone knows Spring anyway. Well, there's nothing necessarily wrong with Spring, but it starts to be problematic if you start using Spring in OSGi. The reason for that is that Spring, and the same goes for Java and most of the other Java frameworks, was never designed to be used in a modular way. So when you get in a modular environment where you have this isolated class loading per module, things break. It was just never designed for that. So if you start doing Spring or Java combined with OSGi, it starts to be really difficult. And you see that things that are normally easy in Spring suddenly don't work anymore in a modular environment. And, well, people, of course, start to complain about that. But that's just because it was not meant to be used in that way. So just don't do that. Just looking at the OSGi space, and, well, some interesting places to look at are Amdatu and Apache Felix project. Everything that you need to build like a large-scale cloud application, say modern web application, it's there. So there's really no need to use those more traditional Java frameworks because it just makes your life difficult if you actually do use them. So if you look at Amdatu, it's completely modular itself as well. So there's no core framework. That's nice because you don't drag in a lot of stuff without actually using it. If you, for example, want to use the Mongo functionality, the only thing that you need is a single jar file which provides Mongo functionality. That's it. And you drag in nothing else. So it's very easy to get started with it, and there's well, very limited lock-in because, well, you only actually drag in the parts that you really use. A few examples. This is Amdatu REST. You can see it's based on JAX-RS, which is the Java specification of doing RESTful web services. The only thing that we did is actually wrap an implementation of JAX-RS, in this case Apache Wink. And we wrapped that up in a way that is actually working correctly with OSGi. So now we can just register a component, which is the way of registering an OSGi service. And for the rest, we're just using JAX-RS annotations as you would normally do. Another example, using Mongo. So the only thing that Amdatu Mongo provides is an OSGi service which can be configured. If you use Mongo in Java, you need a driver. And that's like the low-level API that Mongo provides. This driver is already an OSGi bundle, so you could just drop in this driver and then just configure your connection and start it up and start using it from there. Well, that's inconvenient because then you probably have connection strings all over the place in your code base, and that's bad. In OSGi, we have a specification to work with configuration as well. So you can provide configuration to your components. And that's what Amdatu Mongo provides. It provides a mechanism to have the standard configuration mechanism, configure a Mongo connection, and from there on you just work with Mongo as usual. So it's a very, very thin layer, but with this very thin layer it becomes very easy to use Mongo in OSGi. So in this case we also use some object mapping, completely unrelated to Amdatu, just to show how easy it is to use. We are using the Jackson library here. So we basically can get some products out of a database, and it's all, well, more or less, actually not type safe, but it looks type safe. So this is all you have to do to start working with Mongo. Next reason, you can do plugin systems really well. Well, I think you all, at some point, probably played around with class loaders a little bit to create your own plugin system. At least I did several times in the past. You want some kind of extensibility in your product or well, thing that you're working on, and you need a plugin system. And for that, often you need like fancy class loaders. OSGi makes it very easy. This is literally code that comes from a real product. I'm now to Bootstrap. The top part would be like the core layer in this tool, looking for plugins. So I have one module that looks for, well, other modules that provide plugins. We basically just use the service dependency annotation again, this time on top of a method. And we can have a bunch of other jar files that provide implementations of this interface, and that's all there is to it. We have our plugin system ready. Class loading is not something that we have to be concerned of. That's all part of OSGi already, and this is it. Well, compare that with all the magic class loader solutions that people have been trying to build, including me, by the way. So there's some very good examples in the real world. Amdata Bootstrap is a tool specifically for OSGi development, making OSGi development even easier. Spring Roo is an interesting one. You wouldn't typically, see Spring Roo users talk about OSGi in a positive way, but actually Spring Roo itself is based on OSGi. Eclipse is based on OSGi. That's probably the oldest and the worst example of using OSGi because it's a big mess. It's a big mess because it's very old, and at that time people didn't actually know yet how to use OSGi properly, so it didn't, well, there were mistakes being made, but it's still the best known example. Something different is Glassfish, so also completely based on OSGi. And that actually goes for most of the application servers. So you see that there's actually a lot of tools out there that use this plugin system and use OSGi as their core layer without you even knowing it. And we're almost there. Another reason to, why OSGi development is pretty easy is because it's very easy to do integration testing. Of course, unit testing is easy because we use interfaces all over the place, so mocking becomes very easy. But in some cases, you need a little bit more than just working with mocks, and you actually want to use like real databases and, some part of your system. So in B&D, we can use JUnit, basically. But we can then run this code as an integration test. And that will actually mean that an OSGi framework is started, that the bundles containing my code and my tests are installed in the framework, and that the framework is disposed of again after running the test. Well, because the overhead of running an OSGi framework is extremely low, it takes almost no time to start this test, so it really feels like a unit test. But it gives me the possibility to work with all kind of external systems and services. So that's pretty good as well. And then the last reason. There's a lot of great resources to get you started. And this is, of course, a bit of a shameless plug for my own stuff, because that's my book that I wrote, basically explaining all the things that we've been looking at today. Another nice resource is the Amdata website. Not just because you can find the Amdata components there, but also because we have a lot of video tutorials there. In the last few months, I've been publishing a lot of those. Basically from really the pure OSGi basics, how do you actually create a bundle, how do you do dependency injection, to the more advanced things like how to work with JPA in OSGi. So that's a good place. Part of the website, we also have a mailing list, so if you get started with this stuff and you have any questions, any kind of questions, just don't be afraid to ask. There's a whole bunch of people on this mailing list, always happy to help, so just ask questions. And with that, I want to thank you all for being here, and thanks for your attention.